All right. If you have a problem hearing or seeing something, let me know before we go too far. Can you see the slide up about Madisan?
Yes.
Okay.
You might want to put it in presentation mode though, because we're seeing your slide mode. Yeah, okay.
Okay, I started a company back in 1998, Madisan Information Systems and Analysis, because a book I had written on describing aquifers became Indiana state law, and I had to start a company to be able to get the contract through Indiana University and the regulatory agency. So that was the inception of Madisan Information Systems and Analysis. But what I want to try to communicate today is that geographic information systems shouldn't be thought of as software. It should be thought of as a process by which we capture that which is the most immediately remembered. Images connected to location. When you think about anything in life, you're creating a mental image. And when you no longer can do that, I've been working with the Alzheimer's Association on my freebie side of my life. That's what happens. You cannot recall those images. So when you operate in a geographic information system world, you're communicating with the fastest speed. Everything that I'm talking about, if I'm not very exacting, you're probably going to be wondering, what's he talking about? And I bet you can't create a mental image. But when you can create a mental image, it has a much greater chance of being recovered and stored. So I want to encourage people to get active in the GIS process rather than just looking at maps on some governmental website where you interact only to the degree of the narrow set of fields or perspective of the governmental website. Rather, change the world from a topic at a time to multiple topics to a single location. So Google Earth as a GIS piece of software transforms information flow, builds context. Remember the old forest versus the trees concept and knowing the difference. And through interaction with one map, creating a new insight, you pose a new GIS question. Background, I'm a professional soil scientist, a geologist, undergrad in soil science and chemistry, and biology minors, a master's in geology, postmaster's education at UW-Madison, where I focused on groundwater modeling, geostatistics, which is basically how things vary in space, soil behavior, and geographic information systems. And had a lot of experience looking at glacial sedimentary environments in Iceland and in Alaska. I mapped out 135,000 acres on foot of soils with Purdue and the USDA. So you can say I started out making maps, and that process taught me the value of communicating in that way. I was the supervisor of the Resource Conservation Recovery Act, subtitle C to be exact, hazardous waste hydrogeologist. After writing that manual, I got noticed and was asked to join the prestigious groundwater firm of Garrity and Miller, which later, through acquisition by Arcadis, became Arcadis, Garrity, Miller, and then worked with a variety of engineering firms post that experience. And I started, as I say, Madisan Information Systems Analysis in 1998. And I worked with a whole bunch of consulting firms currently. So I want to bring up, again, some graphical images that I hope you can remember. And the problem is, in all kinds of disciplines, we tend to isolate, information technology folks call it information silos, our perspective. And it becomes hard to relate to somebody else. It might be a client, or it might be how a client relates to customers and so forth. So I'll be using the blind men and the elephant old metaphor. Then looking at historic information flow, how we used to cover everything on paper and how it promoted isolated context. And by simply transforming that into a digital medium, we're not changing things all that much. And so the solution is about building context with a platform of Google Earth. And so I'm going to show you some examples of how Google Earth works. And I normally cover this in about 2 to 2.5 hours. So what I'm going to do is try to go through some examples. And then if you wonder, go ahead. No, I thought somebody was saying something. So when I go through the examples, if it goes too fast, and some I just won't be able to have time for all of them. If we get near the end and you want to see how something is done, just let me know. So the concept of the blind men and the elephant is they can't see the whole picture of the elephant. And so they're given a limited part of the elephant to make a judgment. And so they wonder, which one is the elephant? Is that horn a rhinoceros? Is that trunk a snake? That tail, is that a donkey? So depending what you focus on, you can get a very distorted view of whatever it is that you're talking about if you don't understand the full context. As I say, technologists call this idea information silos. And there's a variety of pictures here where the operations area of a manufacturing process has a language of their own and a very narrow perspective on their objective, and their people over in marketing can't figure it out. And looking at a couple of other ones, down in the lower left-hand corner is a goldfish that's in his own little bowl, and he or she thinks the only way to understand what's in the other bowl is to jump into the adjacent bowl. And of course, that other fish doesn't understand what it's like to be in the other bowl. And if you spend too much time in one bowl after you've been there, you start to only have that perspective. So another way of thinking about this is the old slideshow presentation, where the person making the slideshow knows where they're going. And the people sitting in the audience might have an outline of where we're going, but each picture is a mental image. And the problem is that by the time you're at the 82nd slide on the 82 slide slideshow, it's hard to remember what the first one was all about. The person giving the presentation has a linear connection between it, but oftentimes we only attach ourselves to that which we're all already familiar with. So I, for 22 years, have run a nonprofit, not related to environmental work, but a lot of the folks that volunteer in this endeavor work for Epic Systems, which is a medical records company, the world's largest, where they transformed medical records from an analog sense to a digital one. And a lot of times what happens is that people that don't have to perform in the same way as people making a product will just mimic the analog workflow. In other words, the paper trail. And they'll say, just digitize this because it's comfortable for me. And I want to be able to just recover things in the linear way I'm used to thinking of them. Well, Epic Systems started out saying, well, we're not going to be successful unless we can basically have better outcomes for the central idea. And I'll talk about what that central idea is. So historically, paper records of medical records were organized by body part, like the heart, the cardiologist, the lungs, the pulmonary specialist, and so forth. And you can know everything about one of those body parts, but if a critical one gives out and you can't react to it fast enough, the central point to it all collapses. So they said, well, if we create body part orientation the way that things have been done, we will be having the customer being the specialist, like the cardiologist, and not what the cardiologist is supposed to help. And that brought up the central idea of what should be the center of this information flow. And they decided, I think it should be the patient. So the patient in an information flow way becomes like a bicycle wheel, where the hub becomes the patient and the spokes becomes the body parts in their affiliated clinics and hospitals. So at least each one of the body part people have by design an obligation to communicate through the hub. So historically, information systems have had a difficulty when people couldn't understand how this made anything better. By simply digitizing an analog paper workflow, it doesn't make it interoperable, or in simple language, the ability to be able to work with one idea, like the heart, with your pancreas, let's say. So it was the idea that these isolated information systems are only sped up when you digitize them. So if the information system is flawed, you speed up flawed results. Back in the late 90s, partly because I wrote this manual and I sent it off to the Army Corps of Engineers and the United States Geologic Survey, the US EPA, and all the regulatory agencies in Region 5, that's the upper Midwest, in EPA speak. People knew about me, so I said I'd like to try to communicate the problem in organizing information by regulation. And so I went into the DNR's equivalent of Wisconsin's EPA, and said I'd like to try to look at the relationship between a location and the files associated with that location. So one of my colleagues, Dr. Mumford, is looking at a landfill drawing, and he's pointing out a point, and that point is associated with these laboratory records over on the right. And I asked, could we take a look at one of the larger landfills? And this is about an 8-foot tall ceiling, and there's about 50 feet all the way this way and all the background of paper records about the landfill, for which you had to connect to a physical map, which was physically in another room in a broad-based maps, in other words, large-scale maps. So paper reports and paper maps have limited context and utility. So if you only have this isolated perspective, you can go to a specific location and then query about that location from a limited perspective. But each time that you want to have a new perspective, you have to go with a different app or a different map, a different agency. And what ends up happening, you kind of forget what was the perspective that I just gained from the other agency. And so the spoke idea is this idea up here of Google Earth. It's about taking static maps that are generated, and hopefully you'll be able to understand after today a bit about how you can create these yourself, and streaming maps, literally streaming after they're generated, so that at different scales, you can see different scales of information. And I'll pull up Google Maps. I hope we don't crash. I've done these webinars one way or another over 12 years. And that seems to be the problem, because my download speed is 230 megs, but my upload is about 11. And sometimes that leads to crashes. So if we don't crash, I hope to demonstrate, how we do this today in trying to find things like Italian restaurants and bicycle shops, all within the same locality, but you don't go to a separate website for bicycle shops or tube repair and jump around to the Italian restaurant, because we have Google Maps or Apple Maps that enable us to have the easiest way to recover information. And that's geography in its relationship to other things. So my experience has been largely dealing with the Earth biosphere from the ground down. And when I talk to farmers, I come across this real bad information silo. And it's the idea that they don't even comprehend how much little water there is on the surface of the Earth that you can stick your toes in, you know, in the summertime, at least, in liquid. So on the freshwater side, I should say. So when I asked them two fundamental questions, I said, can you manage anything you cannot quantify? And they go, well, no, you can't. And I go, okay. So how much water do you think that's fresh as a percentage of fresh water do you think is in all the rivers and lakes and streams and ponds in the world? Now, this isn't all the water, it's just the fresh water. And the lowest number in over 40 years of asking this question I've ever heard, if they have 80 acres or 8,000 acres, they say the lowest is 20%. And I go, well, where's the other 80%? Well, I don't know. I don't know where that is. And so part of that is due to this concept of the soil and water conservation district. So if you were to go by that name, you would think that you're conserving water if you're conserving waters in ditches and streams and lakes. But when I tell them it's less than a penny on a dollar, they're just blown away. How could we be focused so heavily on conserving water when it's so little? And I said, well, because that little is what you can see, and it's what we're most immediately in contact with. So this is the water cycle that most people are familiar with: evaporation leading to condensation, and then rain, and then infiltration getting down to groundwater and eventually making its way back to the ocean again. But as this graphic shows from the United States Geologic Survey, oceans, of course, have almost all the water, 96.5%. And 2.5% of that water is fresh. And glaciers and ice caps are 68.6%, groundwater is 30.1%, and surface and water and all other fresh water combined, like Lake Michigan, Lake Superior, the Amazon, the Nile, is 1.3%. So when you add up the parts of that very slim amount, which is shown, you know, up top here, we see that the lion's share of the water is in ice, hence the importance of climate change that really dictates the water-based climatic system of ocean currents and the changes it brings about in the weather system. One of the things to just quickly bring up, I'm going to be using a mouse today so that it's not an unfair advantage, but what I'd like to bring to your attention is this thing called a 3D mouse, which is in the lower right-hand corner. It's like, now I guess it's about $90, but what it enables you to do, it's like a joystick. And it's got a very heavy base. It's, you know, it weighs over a pound. And you can navigate all around in Google Earth very, very quickly, much faster than when you're simply using a mouse. And it becomes particularly important when you want to digitize a polygon. In other words, you want to click, 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 click around an area. If you're using a standard mouse, when you go and drag across the map to make the next click, well, guess what? You drag the line with you. But if you have a standard mouse to zoom in and zoom out, and then this other one, I should say the standard mouse to click and this other mouse to zoom in and zoom out and navigate, it's kind of a navigation mouse. Then you can very quickly create your own maps without creating havoc. I've been doing these webinars since 2010, primarily focused on the rural community and farmers. But as I say to everybody, I said, you know, farming is the only industry that you can readily see with the naked eye from the moon. Even the automobile industry or the steel industry become invisible at over 200,000 miles away. So it's one of those areas that doesn't have a whole lot of regulation, and there hasn't been a lot of people helping the farmers to focus on it. So that's the primary reason why I've tried to give additional focus on Google Earth for them. So we'll clear that and we'll bring up Google Earth. And one of the first things I guess I could bring up, I was going to leave this, but I think I'll leave this on. This is Joplin, Missouri. And Joplin, Missouri was hit by a very powerful F5 tornado. And as we zoom in.
Hey, Mel?
Yes.
We're still seeing your presentation. It didn't switch screens to your Google Earth.
Okay.
So I don't know if you have to stop sharing in order to share something new, or if you can switch.
Yeah, I always use GoToMeeting. I've never used Zoom. So
You should be able to just pull it right in front. So you should be able to grab it and pull it right in front of your presentation. That is one option.
well,
Otherwise, yep,
can you see it now?
not yet.
Okay.
So you'll have to say share again and then pick the correct screen to share it.
All right. Can you see a map now?
Yes.
Okay. This is Google Maps. And I'll get a hang of this thing.
There we go.
Yeah, okay. Then not that this makes any difference, but in GoToMeeting, you just simply, whatever's on my screen that I'm looking at, you don't have to pull it in front, it just comes up. So this is not long after the devastation of that tornado. And to be able to see that, we have to go with a Wayback Machine. And this is one of the most powerful and extraordinarily expensive things to replicate. This is why you don't see it, as far as I know, in any state GIS system, where you can have 30 plus years of aerial photography delivered at will with a slider. You have the ability to download but not to interact in the same lightning speed as Google Earth. So up top, there's kind of a clock. And if we go back in time to 1985, the area that we're looking at, the aerial photography is just outside of our range. So the actual 1985 photography is at a very gross general scale. And if we move to 1996, a little bit better. And each one of these vertical lines represent a date of aerial photography. Well, what I'm wanting to do, and I didn't realize I couldn't do this, is up above here, there is a toggle that enables you to skip from your view from Google Earth directly to go to Google Maps. And so if I do that, I'm not sure, are you seeing Google Maps now?
We are not.
Okay, well, I guess that's a downside of Zoom.
Yeah. But it is a nice feature to know about.
Yep. Yeah, well, it's pretty important because we go back to sharing. Well, what I was going to show, if it wasn't so cumbersome, was the idea that you can narrow down the time before and after a specific event. And in environmental work, of course, you take a look at different land uses and what was there before, what is there after, and what has happened in terms of changes. And I guess the other part of it is that Google Maps, if you've not used a lot, has the ability to just type in anything. I'm just using an example of Italian restaurants. And so what comes up are these restaurants with a little fork and knife symbol. And for a lot of larger cities, the more that you zoom in, the more of the feature that you're looking for pops up. It's something common, like an Italian restaurant. So that's called regionalized geographic information systems. The more that you zoom in, the more that you see of a specific feature. And that's designed around the idea of optimizing on bandwidth so that you don't have to download everything to see the general whole. And as you zoom down, you see more of that classification at a scale that's meaningful. Stop share, start over again. I'd like to show you is what happens when a single professor and 3 grad students link up with the USDA and they say, we can do something better than the soil web survey. If you're not used to it, it's this thing where you've got to go in and learn how to use the soil web survey. And then after you learn to use it, you've got to go location by location. And it's about 4 or 5 steps to be able to figure out what are the nature of the soils at your location. Alternatively, all that you really need to do is to have the single app called soilweb.kmz. The KMZ is what PDF is to Adobe Acrobat. It comes from the old company Google bought out called Keyhole. And they had this language called Keyhole Markup Language, KML. And when they put in specifics of a zip file, they called it a KMZ. So I want to bring up the idea as well. If you're wondering how is this relevant to the work that you do, bear in mind that when you're looking at Google Maps and Google Earth and Apple Maps, you're looking at billions of users and the robustness that comes with getting eyeballs to look at your work, let's say for grants or for the general public to have a better understanding. More people are in this location than isolated information silos that you first have to learn about, even the silo, to understand. You can put your content where everybody is. And it's a GIS for everybody. It's entirely free and has been for a little over 5 years. It was a $400 a year price before. So what this is, these red dots represent, let me pull up farther and farther, represent the soil test bits that were done after a lot of transects to figure out what is the general concept of that specific soil unit in the county. And when you're zoomed up, you bring up a couple other points in the lower right-hand corner. The imagery date for this very general one is December 30th, 2008. This is the latitude, longitude. You can change I have it in decimal degrees, but you can also do that in degrees, minutes, seconds. The elevation of the ground is next, elevation in feet. Then the eye elevation, in other words, if you're like a rocket at 533 feet above, miles, I should say, above the ground. And so they didn't want to overload with all these red dots and they'd just be a blur anyway. So they don't activate that GIS data layer until we get down closer and closer. So at around 75 miles, we start to see the individual test bits. And if we click on one of those and we go to the PED-ON description, which is basically a PED-ON in soil speak, is it's a hole and you're looking at characterizing it. So this is back, in the mid 70s, Shiverly and Henderson did this description. If we go back to get the lab data. This is the individual lab data. Then as we zoom down closer and closer, now at about 14 miles, we see soils from hilltop to valley to hilltop. And these are the soils that you would see. And as an example of the block diagram, this is the cross section of what the soils look like. And as you zoom down even further, now down about 10,000 feet, you have the individual soil series. So we have 3 scales of soils information actively streaming live from the server at University of California at Davis that is directly connected to the servers at the USDA. So when you click on the individual soil name, then what comes up is kind of important things like percent organic matter, percent clay, percent sand. These are cumulative distribution curves, vertical hydraulic conductivity, gypsum content, calcium carbonate equivalency, and so on. Then it has limitations for that soil, like agriculture, pesticide loss potential, and going down into waste related, manure and food processing waste, land application, municipal sewage sludge, and so on. And you see, we haven't left the location, but at the same time that we're getting this soils data, we're not limited. So we can click off the soil web and look at stream gauging stations from the United States Geologic Survey. So here you can download specific data onto your computer, and you can get a variety of different graphs and tables. And there's the stream flow information. The USGS also has a specific map that's updated showing all the stream gauging stations in the US that are running between their 25th and 75th percentile. And of course, they got the 10 to the 24th percentile, so forth. At the same time, you can look at all the USGS groundwater monitoring network. And if you take a look just casually at this, you see there's a cluster of wells. There's only about 100 in Indiana and 100 in Wisconsin, but there's several thousand up here. And the reason is that this is the largest continuous layer in the United States of very droughty, sandy soils. So basically the cows have gotten out of the barn and pollution is extraordinarily easy to migrate to the groundwater. So hence tons of wells, and the same thing applies, not so much in terms of transparency to the groundwater window, but the interest in looking at the Gulf of Mexico and the relationship to the groundwater system. And just looking at any one of these, just pick one from Alabama. This shows the most recent recording of the well. This shows you can zoom in and out actively with this map, the actual location of the well and its description, what it's screened in. Go back to this original area. And again, hitting on this theme of GIS as it applies to regionalized data sets. This dynamically delivers topographic maps based upon the scale that you're zoomed in. So at this scale, I don't know if it's a 1 to 100,000, 1 to 200,000, this is a topographic map. But as we zoom in, and the computer at the server side is waiting for the mouse to stop for about 3 seconds. And once it stops, it then changes the data set and reaches out. Again, it's taking longer here. It's almost instantaneous when you look at it from the download side. It just takes longer getting it uploaded to you. Is this topographic maps that are assembled on the basis of how far you zoomed in. I'll just do one more zoom in because this isn't the most detailed. So we'll stop right there. And to get there, I'm just using my mouse wheel, moving in and out. What I'm going to do now is turn on the topographic model. So you can see those topographic lines in the three-dimensional relationship. It doesn't extend out farther because I drew the topographic map at a certain scale, and it's taking time to have to redraw it. On the left-hand side, in the lower left-hand corner, are standard things that you, the user, are kind of locked into. It's what you get when you get Google Earth. They give a couple of demonstration layers, and they call these categories of layers places. And you can define your own places, and they give it a name appropriately, my places. And you can develop your own content by using points, lines, or polygons. And once you create each one of these, they have unique features that you can bring the power to bear of GIS. Unfortunately, they got away from the official GIS speak of points, lines, and polygons and just called it a place mark that I think they used a thumbtack. And so they're trying to use a vernacular that people can understand. Polygons and lines are polygons, and lines up here, points, polygons, and lines are given the name of a path. And I think part of the reason they call it a path is the dynamic way that you can interact with the data. So I could either click on the N, like if I had this thing rotated on top, or I can just hit the letter N on my keyboard, which I just did. If I hold down the control key and move my mouse wheel, I can move around a point in any direction and get back to true north just by hitting N. And if I want to get to the look straight down, I hold down the shift key and use the mouse wheel. Shut off the topographic maps that are now drawing themselves. And take you to a farm that I've been working on for a number of years. And again, using kind of the Wayback Machine, you can see what this farm was like. Probably better resolution photography in 1992. It was kind of a traditional farm in terms of, row crops and so forth. Then in 2005, they started to expand the farm. I don't know if you can see up top here on your screen, but I'm now up to September 2010. So what I'm going to do is go back to 2006, and we did a 3D laser survey of this farm down to a centimeter of accuracy, where you just do a number of setups and you can get elevation and 3D dimensional objects. And literally we have the barns. And in another project that I'm not going to present here just because of time, we went inside of a factory and did a 3D scaling of everything inside the factory, because they made air conditioning parts and they made them to order. So they did them for hospitals, for large buildings that needed specific requirements in their building. So they had to move machinery around. So we did a GIS project where we showed every bolt on everything so they could see where it would fasten. And each one of those three-dimensional objects can be brought into Google Earth with a secondary app called SketchUp. So I'm going to turn on various layers here, and you'll see that they're not connected to anything in this air photo because this wasn't done until about 2011. So we go to the modern survey, you can start to see where these stormwater drains are connected. These are the stormwater pipes. These are the water lines. These are the electrical lines, the underground. This is their manure lines. And one of the other features of this, and this is something that I've used more times than you might imagine, is the ability to link other dynamic data like YouTube to a polygon. This is a polygon representing much of the primary farm. Across the street is their cheese factory, and they move the milk along this water line to the cheese factory. And because it's kind of a traditional, multi-thousand, 1,200 cow farm, but they graze their cows and they are keeping track of their carbon use and having reducing their carbon footprint by using, to a degree, using the manure digester. And then the manure digester creates electricity, which they sell off onto the grid. And then from there, they take the waste product and convert that into dried manure, which after drying it becomes bedding for the cows and fertilizer for flower pots. So when we click on this, you get a little blurb about Crates Homestead Dairy. But I did the same sort of thing for the Wisconsin DNR, like Wisconsin's EPA, where we had to do a high capacity well test. And we had stopwatches showing actual video of showing the line being turned on, and then the flow meter showing the speed of the pumping. And then that was linked in a hyperlink to the actual GIS, so that they got a GIS map that they could click on and see the documentation of the field work. I also found errors in the USDA soils map that I was able to, with a couple of different computer monitors, show the old map, the new map, and with a trench for their new high capacity well, which is out here. And we moved it away from the manure sources and their fertilizer sources and so forth, that they had incorrectly changed the soils names. And that was by virtue of having the live streaming data compared to the old static paper copy that was digitized. So as changes were made, I could see them dynamically. So I'm going to zoom out to Indiana in particular, because it was one of my colleagues there that really helped to get past the information silo in a way. He said, wouldn't it be great if we had county, state, and federal GIS data all in one place? And long story short, he convinced the governor of Indiana, which was a Republican by the name of Mitch Daniels, that it would be smart to expedite the speed at which GIS data could be made available. So they have a marketplace for Indiana GIS data where you can go like Amazon and grab the county data, the state and the federal data, and download it instantly, rather than having separate county units of government with their own policies for getting everything. So I'll just bring in a couple of these. These are the brownfields in Indiana. And some of this is just very simple stuff, like, you know, the lat long and the zip code and things like that. These are all of the National Pollution Discharge Elimination System pipes in Indiana. This is industrial waste sites. And I should add that when I wrote that manual, I did it for free. When Roger was doing his work, he did it for free, but we both had a supervisor that kind of supported us. And the same thing applies for this dynamic deliverable of these USDA maps. It was never a committee. It was 1 or 3 people that made huge differences. And I think one of the important things about this whole process of Google Earth is that unless you use something in a dynamic way, you're just an observer of somebody else's work. It's like picking up the paintbrush and creating your own images. When you draw a line using this path tool, and again, it's just as simple as clicking a couple of points. I'm just going to get rid of that line. and just use this line, and I'm going to right mouse click on it and click elevation profile. And as we move across the topography, we're using the same 10-meter digital elevation model, which is, basically they take a 10-meter by 10-meter square and put the centroid point of the elevation. That gives us the one to, it's 24,000 USGS topographic maps. That's exactly what Google Earth uses. And so you can see the slope, the 70% slope, because it's literally a cliff. And as we go down to the railroad track and the road, and then we come back up again, that you can see topography. This is literally the GPS from a car. And GPSs from a car or on your bicycle, if you're a road racer, all create, if you set it on your computer on the head unit, a GPX file, George Paul X file. And once you do that and you right mouse click on it, you can create a speed that you were traveling in an elevation map. And we use this for a omega-3 cheese. In other words, it was higher content of omega-3 content because they used a type of forage from Canada. So we tracked the trucks from Canada all the way to here, and the trucks can be seen, on the trucker's GPS, obviously. And then as it's downloaded, we can, see the speed. And if you have a manure truck, you can see what the manure truck was literally doing. Is it just sitting there? Is it moving? And do things make sense? So again, the right-hand side is miles per hour and the left-hand side is elevation. In part, I'm showing you some of these things that may seem kind of off the left field from what you do, because what I'm hoping is that I connect with some of you post this discussion to show you exactly how to do this. And as I've done a lot of things in my life, it's entirely for free. I don't charge for doing any of this.
Hey, no.
Yeah.
Definitely lots of interesting. We got about 5 or so minutes left in our normal time, especially since some of the people have a meeting immediately following this.
Yep.
So I figured now might be a good time to wrap up, and if there's any questions that people might have.
Right. Well, just one other thing. I just want to go across it's these points, lines, and polygons. And when you click and generate one of these, the box that comes out of it is just an HTML web page. So you could grab a web page and just copy and paste the HTML language, and it would pop up, and it would be your basically your text for whatever the place mark. That's exactly what happens when you go to Google Maps. Is they're just using HTML language. The other thing is that if you have historic aerial photography of an area all the way back to the 1600s, and you have control points, you can do a process called rubber sheeting. And rubber sheeting basically takes like street intersections and connects them. So this is the 1857 map of Chicago with the 3D buildings put onto that 1857 topographic map. But you can do historical renderings of whatever, back to the 1800s or before, as long as you have a map and control points. So I guess one of the things is, does anybody have any questions about what this could do by looking at kind of a quick brush through on this? What I encourage you to do, so I don't hear anybody jumping at that, is
Yep.
just type in anything in your work, like air monitoring models, KMZ. Type in, anything that you're actively doing and type in KMZ. You're going to find that there is a ubiquity of files that go into Google Earth, and the value of the file is who originates it, because there's, just like Facebook and anything else, just because it's on the internet doesn't mean it's true. So you've got to look at the quality of the data. But at the same time, once you start utilizing Google Earth and the power that it has by being able to incorporate every major geographic information system type of file simply by going to file and import, you have all these different file importing capabilities and overlaying it to whatever you have. I would say that if you don't do this, you're kind of stuck in somebody else's view of a project, and that's very self-limiting.
And Noel, I would like to thank you very much for your presentation, the time you've taken to put it together and discuss with us a topic that's not typical for a technical subcommittee meeting. But again, I found it very fascinating to see all that you could do with Google Earth. I think I could have spent another hour just going through and just wondering the US.
Yeah, it's hard to look at even the breadth of what it can do by way of example, let alone show how you do it. But I can tell you that I've worked with multiple county and city planning departments in developing GIS for citizens, and ended up on, for example, the city of Madisan, Wisconsin's website, and then being able to download the file so people can have a vision of where we're going, for bicycle lanes, looking at brownfields, what are the options for what might look like, and doing three-dimensional renderings in Google Earth. The more that you can democratize GIS, the broader your audience is. Because if an audience doesn't know about it because you're not in the hemisphere where they reside, you're going to be limited, not only yourself, but the number of people that can see the reason behind what you're doing.
Well, I again appreciate your presentation. I would say with me particularly, keep in touch. It may be that there may be a meeting within Indiana where it would be very interesting to hear you speak more on maybe specific subtopics relating to mapping, relative to maybe certain areas where we try to do some type of compliance assistance as far as environmental regulations. So Noel, would you make your PowerPoint presentation available to us?
Well, yeah, it's kind of brief. I certainly can send that over to you.
Okay, I appreciate that. I do want to mention, and as people are leaving, maybe this is going to be short, but Jennifer Dixon has agreed to be the co-chair for the technical subcommittee. As of now, there's no formal presentation for the August Zoom call, but that would just be an opportunity to maybe discuss what's on people's minds or what they would like to see, or just have an open forum and just, hear whatever happens. We do have a presentation, Julia Black, and I would like to thank Jennifer Wittenberg for suggesting the idea. She's going to speak on air trends and the formal report made by EPA on September 20th. I'm hoping that, with Donovan's contact with EPA, that there will be someone who will speak on SEDRI CDX basics. We'll see where that goes. Without further ado, I would like to thank everyone and wish them a good afternoon.
All right. Thank you, Mark. Thank you, Noel.
Mhm.